Okay, I've got 12 seconds.
Okay, you're live.
All right. Welcome, one and all, to the Los Angeles Astronomical Society General Meeting of December 2025. I usually start this off. Yeah, I'll take that round of applause. I see Justin out there. I'll take it. There you go. I won't make you do a wave. We're a little sparse for that today. Oh, from the top. All right. Excellent, excellent. As is tradition, this is where we like to out the new members. Are there any here that wish to introduce yourself to the crowd? We got one. They're always at the top and in the middle.
Hi, we're Katie and Brian.
Oh, we'll take a Zoom one. What do we got first?
Katie and Brian.
All right, go for it. Katie, introduce yourself
Hi.
to the crowd.
Hello, I'm Katie.
I'm Brian.
Nice to meet you guys. Nice to be
meet y'all.
here.
And what brought you to LAAS?
The sky.
Interesting
This-
choice. Interesting
Right.
choice.
Seemed like the right place to be. To be
That's
able
true.
to
That's
be
true.
around people.
Now,
with the
just to be
sky.
specific, we generally lean towards the night sky.
Yes, the night sky.
But not entirely. Not
That's
entirely.
more. That's much more specific. That's better. Yes, the night sky is what brought us here.
All right, I just want to make sure that you got to the right Zoom.
Yeah.
Absolutely.
Okay, good. All right, well, welcome. Even though you're a Red Sox fan, still welcome. That's cool.
Thank you. Can't help it. From Maine.
That's fine, that's
all
fine.
we have.
We'll allow it.
Okay, cool.
You got the Art of War book over there too. We could go on and on here.
We could. Our house is a fascinating sand tray of stuff. So
I'm already in there. Is that a pull-up bar in the window over there?
it is.
That's for
And you got bugs?
hanging laundry
It's mostly for laundry,
Yeah.
but if you want to come over and do some pull-ups, go for it.
or hang laundry.
Right.
All right. Don't threaten me with a good time. But I'll let you go. All right. Well, welcome.
Thank you.
My name's Dakota. I'm a teacher from the Valley, and I have an academic interest, and I wanted to learn more about astrophotography. And I just moved back from Europe, and I don't know anyone here anymore. So I thought this was a good way to meet people. Dakota, like the state. Yeah.
All right. Welcome. Well, we're actually going to have a seminar on astrophotography, and we have recently built an astrophotography training kit. So you've come to the right place, even if you want to do pull-ups. What's up, fellas? All right. Here we go. Say something. Why are you here?
Hi, my name is Jessie, and I'm interested in astronomy, and I just joined the society this year.
Hi, my name. Oh, let her get her claps. I'm not trying to steal her thunder. Hi, my name's Denise, and I'm a first-year member as well, and I am interested in learning about the universe. And we've been to Lockwood, and we've been to the Mount Wilson events as well.
And you still chose to come to this, so that's good. We're off to a good start. Thank you very much. Is there anyone else here or abroad that wishes to make our presence known? Good. It's going to be a busy night. We have our tradition. So what's going to go on tonight is we're going to start with announcements. Usually we go to our speaker first, but since we have several speakers, we're going to get the announcements out of the way, especially because we got a really juicy one here for you. Then I'm going to do my Good Heavens Proclamation, which is my personal thanks to a particular member of the month. And then we're going to give away some door prizes. Then I'm going to tell you what's going on. And that is what's up. So, with no further ado, Spencer, do you want to throw the slide up? Because we had the elections. And I would like to announce the results of said elections. As per your request, and because you didn't have another choice, you got to look at me as president up here again next year. Yeah, I know. Dry heaves all around. Yeah.
All right, here are the results.
Yeah, I know. Seriously, I'd like to thank my team for working hard. That's right, and yeah, that's right, and I will do my best to serve you all, unlike my opponent, who is totally in it for themselves. Our vice president will be Laura May Abron, who I believe is out there.
I am here.
I'm really, really happy about this. Laura May has been an excellent board member over the course of the year, and a really proactive member and a super person. Secretary will continue to be Spencer Suhu because no one else can do it. Like literally, he's done such a great job. He's kind of built himself an infrastructure. We all should really be eternally grateful to Spencer. I mean, there's a lot of things that we all sort of take for granted, and if he were to step away, you would be shocked at how many shadows there would be in the sunshine that is the club. Our treasurer, firstly, I would like to thank John O'Brien for being treasurer for so long, and he's done a fantastic job. But I would like to thank Greg Thompson even more for becoming the new treasurer. Yeah, I know. So yeah, exactly. So all bribes will go directly to Greg Thompson. No, but I wanted to. That's how we do governance in the United States now. Okay. Yeah, got the right crowd. Whew. That could have gone either way. Oh, you guys are so great. What a cool crowd. Okay. All right, board of directors. This is where it was a little contested, and I would like to re-welcome Roman Telesnikov, Ted Moss, Jason Fields, Shane Winter, and Andrew Inohara and Dave Yakerson back to the board. Thank you all for doing such a fantastic job last year and in years past. And I'm really happy that they were all rewarded by being elected to be back. And then I would like to welcome the squeaky clean, brand new board members that have new board member smell, Cassandra Holmes and Nadie D. Oliveira. And we're bringing back Joe Phipps. This is awesome. I asked Joe to see if he would run again, and he did, and I'm thankful that he did, and I'm really happy to have him back as well. Okay, so that's the election stuff. I'm really looking forward to working with you all in the coming year, and I hope the feeling is mutual. All right, the next big announcement is the banquet. We haven't put the official bouquet of information online yet, but here it is. Hear it from me first. The banquet is on January 25th in the same place at the Quiet Cannon in Montebello. Look for the sign-up sheet soon. You should come. It's super fun. You get to see Joe Phipps in a suit. Just for that alone, it's worth it. But it's a lot of fun. It's a great place to meet members that you've only seen on the group's IO and in winter clothes at Lockwood, and it's much more conversational. So next up would be, how's that? You, Curtis? Next would be the continuing request from Ed Dempsey to share with him your love for astronomy and the club on the group's Instagram. Should you be an Instagrammist, reach out to him on DM him directly at the club's at the club handle, which is LA.Astronomical Society, and share, and then he will reshare. And the last announcement will be coming from our, what do we call it, the bulletin editor. Here it comes. Get ready.
Hi, everybody. I just want to throw it out there that the bulletin has been going really well for the past couple of months. And most of it comes because you guys send me articles, send me pictures. And I just want to go and throw that out there and make sure that that keeps a rolling. Sometimes we've been getting a little thin, but people have been participating, and I really, really appreciate that from everyone. So if you've got anything new to put out there in the world, if you've got anything old, if you've got something scientific that you've been working on, or please do a short write-up and submit it, and we'll put it in the bulletin. I mean, share with the class. That's kind of what it's all about. So send it in to bulletin@laas.org, and it'll come straight to me, and I'll probably put it in the next month's newsletter. Thank you very much.
And the cool thing is, however however proud you might be of it, when you send it to him, he's going to make it look 4 times better. I mean, if you haven't seen the bulletin, it looks like we look cooler than we are. He's doing a really great job with this. So thanks to Michael for that. That was one thing that he was chomping at the bit at about this time last year. And then huh? No, chomping. I'm the president. It's chomping. I got reelected. You guys chose this. The door's over there. This is fun. All right. I guess I have an election coming up about this time next year, so I'll cool it in the next fall. But for now, you're mine. Okay, I think that got us through the announcements. I'm gonna, like I said, I'll get into the Good Heavens bit towards the end after the speakers. So I think we should get to the speakers. First up will be Dave Nakamoto, the jewel of Garvey Ranch Observatory. Yeah, that's right. If I could look you in the eye, I'm gonna make it special. No, I'm going to be doing it for him. Yeah, exactly. So if the slides don't work, get ready for some astronomical interpretive dance by me. You can. All right, come up here and talk. All right.
Okay, I guess I better use this one, and hopefully this thing will work. Okay, for those of you that have been asleep all this time, we have one other permanent facility. That's Garvey Ranch Park Observatory. If you're not familiar with it, it's very simple. This is a map from Google Maps. It's basically you
Dave,
get on the 10
nothing's
you get on the
showing on
10
the-
freeway, you head south on New Avenue until it T-bones. It'll end T-bone into Graves. You hang a right on Graves. 2 stop signs later, hang a left, and you should be. Wish I had a pointer, but that won't help the people online. You
Dave,
you
you're not
see it
showing,
right here,
It's not showing, Dave.
and
We're not seeing
oh, there
it
we
yet.
go. I'm not, huh?
We're not seeing anything.
Share it.
Okay, here we. It's a blank
We got to
screen.
start over again, or I do. And people wonder why I have a distrust of computers. I've been working with it in 1975, so I predate PCs.
There we go.
All right, now we got it.
Now, can you guys online see it?
Yes.
Yes.
Good.
Gone
What you're
again.
looking at is Google Maps. I'm going to start over again, so start the clock over again. Basically, we have or rather, the city of Monterey Park has a observatory at Garvey Ranch Park. And I believe only the city of LA owns another observatory. Everybody else, every other observatory I'm aware of, is either owned by a university, a college, and maybe a high school here and there. But for a city to own an observatory, that's rare in LA County, if not all of Southern California. I'm sure San Diego has one. But basically, you get on the 10 freeway, you head east, you get off at New Avenue, you head south, and don't worry because New Avenue will T-bone and end, and then you hang a right, you go 2 stop, taking notes, right, people? You take, you take 2 stop signs, turn left, and this is where it gets a little tricky. There we go. Now I wish I can expand this, but see on the right side of the road there seems to be a driveway that's very short. It's not short. It's immediately heading down the hill, which is why you can't see anything. Now, you can see the observatory from here if you know exactly where to look. And the reason I say that is because we had longtime residents, 20, 30 years, they come into the observatory and says, I've been living here 20, 30 years in Monterey Park. I didn't even know this observatory is here. You can see why. You can't see it from the road. I don't know off the top of my head. Just Google map it. Because it's a park. Okay, for some reason, this thing doesn't want. Good grief, come on. All right. I'll do it this way. First, I gotta find the cursor again. Don't move it, Spence. I'm using it. If I can find it. Let's see if this thing will work. There it goes. There we go. Even if you get to the bottom of that driveway and to the entrance of the parking lot, can you spot where the observatory is? I can't. Trees are in the way. That's one charming feature about this observatory. Once you get to the far end of the east parking lot, you can finally see this thing. And even so, people have been walking through the park for years and years. They never noticed this. And they tell me this. That's how I know it. That's another view of it. And this is what you'll find inside. Now, curiously enough, the whole building, including the observatory, was dedicated and open to the public in 1965, according to the plaque at our front entrance. The building is still the original building. The dome is 2014. And I won't go into why it got erected. But as soon as we realized that it's safe to put equipment inside this dome, that's when we started upgrading everything inside. What you're seeing is that white tube is an 8-inch f12 refractor. If you look just behind that and above it, you see a black tube refractor. The white tube is used exclusively for visual views because we need all the aperture we can get with this light polluted skies. And the black one, which is a 4.7-inch f8 for wide field and an f24, yeah, I said it right, f24 for planetary views, is our imaging scope. Ah, there we go, and that's the other end of it. Obviously taken in daylight. Oh, here we go. And because of light pollution, and I mean to the west of us, we've got trees surrounding the whole place, so our horizon's limited. We got a huge reservoir to the south of us, which limits our view, and we got a hill with houses on it and trees to the east. So this site is not pristine. It's just light polluted like crazy. It's amazing that we can get a view like this. As you can tell, this is the Orion Nebula. Now I got to go up here and read it because I think this is M15. Yep, that's what it is. Okay. Probably. Well, no, those are elongated stars. Our tracking, we don't have an auto guider, and so occasionally we get the occasional blip. Then we do get some of the brighter comets. This is Comet Lemon, and you can see the two tails right there. This is going to be quick. And about a month ago, I said, I know it's in the sky, so let's try for NGC 253, known as the Silver Dollar Galaxy. And I'm surprised any of this came through, and quite a bit came through. And as you can see, we got photobombed, probably by Starlink again. Much more to my surprise, this is M33, the Triangulum Galaxy. Why is it a surprise? I only expected to see the core. I didn't expect to get these spiral arms. Now, to get this view, we have a lot of light pollution that was in the original raw photograph. And there's various ways, there's 3 or 4 techniques I know of to try and get rid of it. Depending upon how much light pollution there is and what the object is, I employ any combination of them. And this, for those of you who recognize it, is the famous double cluster. By the way, just a plug, it isn't the only double cluster. There's another one I know of, which I'm going to photograph this Wednesday, if I get a chance, is the pair NGCs, 1807 and 1817. They're in Taurus. They're much fainter than this, but it's a good pair. There are quite a number of pairs of open clusters up there. This, for some reason, the most famous. It is one of the more colorful ones, and it is one of the more brighter ones. So maybe it deserves that moniker. And that's pretty much the end of my slide. So I'm not sure how much time I left for questions. I won't answer any questions concerning astrophotography, time exposures, or stuff like that. I think that's appropriate for another time because you can get really deep into that topic and a lot of questions. So anybody, just raise your, if not, yes? Oh, thank you. I knew I forgot something. We're open every Wednesday night, rain or shine, but of course we don't open up the observatory unless A, it's not too cloudy, we'll open it up. But if it is too cloudy or, God forbid, raining, we're not going to open up the observatory. But the facility, we do our mirror making class there. We have a small meeting room where you can come and jaw about things. And we have plenty of grass outside the door for people to set up their scopes. If you have a question concerning your scope, your best bet, if you can make it, is to come by on Wednesday night, set it up, and if we're able to, we will answer your question for you. And that's open to all members. I'm not sure, Tim, do you know if we're open to the general public to do that?
Be open to the public because it's a city facility.
Yeah, but do we have to give them advice on their scopes?
Get the hell out of here. I don't think so.
We do what we do. We do what we do. We're a friendly bunch.
And we have.
Oh yeah, we have coffee. You're gonna
Made coffee.
yeah you're not gonna miss Starbucks. In fact, you're gonna forget about them. That's how good our coffee is. Yes. Yeah, this is my right.
I know, I got it.
Okay. Yes, sir.
The mirror making class, is that like continuously running or do we have to start in a certain time?
So wait, real quick, so the Zoom people can hear. The question was whether the mirror making telescope building is a continuous thing or if it's segmented. Is a good way. I can answer it if you want. Sure. Yeah, it's done in classes, so we're trying to make sure everybody finishes at the same time. So this current batch of telescope builders are getting close to the end. I think like definitely by next spring, if not by the end, like midwinter. They'll be done, and then we're going to put out a big hullabaloo. I'll be flapping my arms around trying to tell people that we're ready to start the next class. And the way that it's being taught is as such that the people that are taking it will also be able to teach it to next generation. So, yep.
We did do it where you could start whenever you came through, but that guy no longer teaches the class, and when he did it that way, it was kind of a mess, in my humble opinion. So we'd rather just everybody start, everybody stop, everybody start, everybody stop. That way we can keep some control over things. Let's see.
And
Any other
everybody's
questions?
building the same telescope also, just so, you know, yeah. Yeah.
Yeah, because you can support one another, and in case, gee, I forgot what he told me what to do. You can ask the guy next to you.
Right.
Can you,
Plus, I
can
mean,
you-
it's
Hope you didn't forget.
And it's been the group has gotten to be a pretty tight knit organization. They're like looking out for each other, and it's like almost like a little, I don't know, almost like a congregation in a
Yeah.
way. Yeah.
can you do it if you don't know
get a telescope.
anything at all?
Yeah, that's the whole point of it.
Okay.
I think
okay. Cool.
everybody in the current class didn't know a thing about pushing glass.
Now they know three things.
Well, yeah, but they've been at it for weeks and weeks and weeks. Give me a break.
David, are we a bit now? Are we a bit? Okay.
Who else?
Any other questions for Dave?
There are a couple in Zoom too.
Okay.
Okay, hit
What do
it.
we got, Spencer?
One from Ron. What filters and processing software are you using? And then I think Kathy raised her. I think I saw Kathy raise her hand.
Okay, let me answer that first one, and then you can see what Kathy wanted. Pretty much any image processing software, general image processing software, will do for the final stages because they all basically contain the same things. I happen to use PaintShop Pro only because I've been using it since 1990. Yes, I've been at this a while. But I also use programs like I got to spell it, GRA capital XPERT, to remove light pollution, but it doesn't always remove it all. But it gets a first good start. And then there's various techniques under Paint Shop Pro that you could probably find in, Photoshop or other things. Given the conditions at Garvey, I don't feel, and my own personal leniences, I don't feel like getting too sophisticated. And as you can tell, I got fairly good results. And what did Kathy want?
Kathy, go ahead.
I was the one that, oh, is there another Kathy? I was the
No.
one that was wondering if anyone could do it.
Okay.
Do what?
Make
The glass.
the glass, push glass.
All you need is 2 arms, 2 hands, feet to stand on, patience, and some grit.
And
Okay,
Wednesday
I got
nights.
those.
And Wednesday
And
nights
Wednesday
and a
nights.
mirror blank.
Yeah.
Okay, all right.
Question, Dave. After
Okay.
your mirror is done, what support do we give to making the rest of the telescope?
Oh, it's all together. You finish with a telescope. It's more than just a mirror. The mirror takes the most time.
Actually takes all of it.
Yeah, pretty much. No, there's been accommodations made for the stands and everything and focusers. Yeah. In fact, actually, one of the members 3D printed focusers for everybody. It was really cute.
Wow.
Yep.
Wow.
Yep. Anything else for Dave? Going once? Going twice? All right. Thank you, Dave. Yeah, I know. All right, Gary Fine is next. He's right here. All right. All right.
Thank you. Thank you. Hi, I'm Gary Fine, and I've been a member of LAAS for maybe 40 years. And we all have our woes with light pollution. So let me just ask you something right here. How many of you have a telescope at home by the name of the Celestron Origin? Anybody? Great. Okay, so let me tell you about it. I used to go up to Lockwood Valley at the Steve Kufeld site with a friend of mine, and I used to do only visual observing. We used to look through an 18-inch f4.5 Dobsonian. And, well, my friend passed away, and it always took me about an hour and 45 minutes to drive to Lockwood Valley. Well, I started viewing from my own backyard, my own light-polluted sky backyard, which is probably Bortle 8 sky or maybe Bortle 9 sky. And I'm really lucky if I can see anything more than Sirius. As far, I can't see Procyon 2. But other than that, I don't have many stars visible because of the light pollution from Los Angeles. So about a year ago, I noticed there was a telescope, and it was called the Celestron Origin. And I started to read about it. It wasn't a visual telescope, but it was just, for taking pictures. So you can't look through it with any eyepiece. However, the telescope, which is a 6-inch, and it's an f2.2, once you take it out, the whole thing, the telescope comes with the telescope itself, which is a Schmidt Cassegrain. It comes with its own mount and its own tripod. And you don't have any wires or anything to set up, because I probably would not know what to do with the wires. And so I checked out the telescope, and I thought it was just fantastic as far as its ease of operation. And the ease of operation is that you take it out, the whole scope, mount, tripod, weighs about 33 pounds. And so I'm able to take it out with the mount and the tripod, and it doesn't have any wires to set up except one small wire that goes from the mount to the telescope itself. You press start, and it has a Wi-Fi connection that will go from the mount right to your iPad or whatever laptop you may have. And then you says start, and then it will start slewing by itself. It has its own internal plates so that it knows where the telescope is in the sky, where it knows where the mount is pointed. And after it slews around to find other stars, and that takes about maybe 3 minutes. Then the next step is it focuses, and after it focuses, and it's all focused, it said, "Where would you like to go tonight?" And I say, "Well, maybe Las Vegas," but it doesn't do anything with that. So then I would give it some object like M42. And when I press M42 on search, or it also says tonight's best, so it gives you suggestions. So then I put in some suggestion, telescope will slew there and be dead center every single time. And I couldn't even see any stars to point my telescope or to anything like that, but this of course allows you to take pictures. Then you can, its default setting is 10 seconds for each picture, and you can set it for as long as you want to. So in other words, not set it, I can go 10 seconds, 15, 20. Celestron suggested in my light polluted skies, they say don't go more than 20 seconds with your light polluted skies. So then what I do is I just check, and it goes onto my iPad, and the detail that I see on my iPad as it grows more and more in color and detail and more color and detail, which is all new for me because I never did any astrophotography in my life, being strictly visual. And the pictures are so awesome that even though I used to look through my friend's 18-inch telescope, Dobsonian, at the Steve Kufeld site, and it was awesome at that time. But what I see now with the 6-inch is just amazing to me, and I really appreciate astrophotography, and I also appreciate like David. You know, David knows where all the wires go, and he knows how to set everything up, and he's been doing that for years. But for me, brand new at anything with astrophotography, I really appreciate the Celestron Origin. And I'd like to show you some pictures, first of the Origin and its setup, and then some of the pictures that it takes from my light polluted backyard, which again is Bortle, about Bortle 8 or 9. So let me just go ahead and let me show you the first set or the first picture, and yeah, maybe you can show me where to hit that button. Okay, so this is just let me go with a few different buttons here because that's not the first one I wanted to.
That's
okay.
Dave's.
Okay. And the Origin, I also want you to know that the Origin is a telescope. It's a Schmidt-Cassegrain, and so the actual diameter of the sensor, it uses a 178C Sony sensor, and that's about 1/3 of the 6-inch aperture is taken up by the sensor itself. So we'll see if we can get to any of the pictures that I've taken just to show you. And the telescope, so yeah, okay, so there's one. So this is taken from my backyard, and again, and of course, so this is the Andromeda Galaxy. And this is really without retouching. Okay, up and down, thank you. So this is without really retouching. And again, the black sky really is amazing to me with the pictures here. Okay. And then again, here's another one of the galaxies that I shot. An average time for me shooting,
M81.
other than the Orion Nebula, which is a lot faster, average time for me shooting is probably about, I would say, anywhere from 30 minutes to 60. I have shot some pictures for 2 hours. And then this is, of course, the Orion Nebula. And then this next one is with me adding some little bit of color to the Orion Nebula. And this is amazing. I can get it from my backyard. This is the Horsehead. I never would dream that I can shoot the Horsehead from my own backyard. And this is, again, another galaxy. I believe this one is, I think it's 4565. 4565 and NG 891 look very similar. I think this is 4565, though. Is that right? Okay, thank you. Thank you, David. And okay, and of course, this is the whirlpool. And it just amazes me from what I could do with my from my own backyard. This is Hercules, of course, M13. Another galaxy, and I don't know which one this is. I don't know if this is the fireworks galaxy. I'm not sure, but another galaxy shot. Another globular. Oh, this is the fireworks galaxy here. Okay. And this is the setup. This is what it actually looks like, telescope. So you can see, it's a short tube. It's only 300, and by the way, it's a 335 millimeters, so it is not good for the planets. It is not good for the moon. And this is taking a look at the sensor right inside the tube. And you can see that the sensor is large. It's about 33% of the 6-inch diameter. And this just shows the hookup between the telescope and the mount. So that's it for the pictures of the Celestron origin. And it really kind of gives new life for my astronomy life, because from visual, going from Lockwood Valley and then just observing from my backyard makes a huge difference now, taking astrophotos, and I look forward to it almost every clear night. Okay, so that's it. And are there any questions? Okay. David.
No hand paddle?
Say it again?
No hand paddle?
No.
Whether there's a remote or not for it.
No hand?
No. Is there a remote control that it comes with, or is it all just from the?
Oh, yeah, let me say this. There's no real controls. I mean, you could do some extra color saturation and things like that. But other than start, there's nothing else that you need to do. Some astronomers on Cloudy Nights forum, they now use a wedge. I didn't mention this is Altaz only. So some astronomers on Cloudy Nights forum are now using a wedge, and some even learned how to use a StarSense Astro Guider. And by using a wedge, of course, you can get much longer shots. So at least they're trying to make improvements as is. And you had a second question?
Oh.
Okay, good.
Andy, what's your question?
Okay.
How much does it cost?
How what?
How much does it cost?
Oh, good question. It costs $4,000, and there's been big discussion, on Cloudy Nights forum, and they say, well, I can put together this and that and that and that, and you could, except for me, it would be too many wires, you know, to have separate components and putting them all together, because I always need to go simple.
Oh, Katie, a wedge is basically a way to convert an out-as telescope to an equatorial, and what that will do is it'll track a little better, and you won't have field rotation in your images, so it'll always stay in the
Yes,
same
exactly
orientation.
right. Yeah, because it's
Longer exposures.
altazimuth, you
Yeah.
do get that
Okay,
that
cool. That's
rotation.
cool.
So if you're shooting for long periods of time, you do get that rotation in your images, and that's something else that the wedge will actually be able to stop. Yeah.
Gary, another one actually is a really good question for a RASA like that one is did you use any filters, or can you use filters with it?
Can you use what?
Filters.
What a great question. Thanks. I totally forgot about that. It comes with its own nebula filter, and it comes with a built-in clear filter. You could take out the clear filter, but you need to keep it in if you don't have a nebula filter in there. So the nebula filter comes with the telescope, and of course I've taken shots without the nebula filter of nebulas, and with the nebula filter, just to check to see the difference. And there's a very, very big difference between using that. I've also used filters that I've bought that fit inside. It's really easy to change filters. So I bought some other filters from some other companies just to see the difference. And there is a slight difference in the different filters I've used, yeah.
Right, and we're assuming the one that it comes with is probably a dual band. It's probably a high contrast filter. I would imagine that it comes with. Does it say?
Yeah, the nebula filter?
Yeah, it's a high contrast. Yeah, it's not an oxygen 3. Yeah.
Yes, it is.
Right.
Yeah, that's like an oxygen 3 filter, yes.
Right, and I wouldn't imagine that it has a solar filter option for it.
No, it does
It's not the right scope.
No,
for that.
no solar filter option for it. And again, I would love to see another so-called smart telescope where I can shoot the planets and the moon. But because it's only 335 millimeter, you need a much longer tube extension, or you need some other modern day AI or something that will eventually give us that.
Okay, I think.
Couple more questions on Zoom.
Yeah.
Start earlier?
Early than what?
You don't have to wait till the atmosphere calms down?
Oh, as far as the atmosphere coming down and things like that, if you have a calm atmosphere, then of course you're going to get a much better shot. And last night I shot I was doing some shooting of even the Orion Nebula and some others, and I noted there's a huge difference because the moon gives so much light that it doesn't do any justice to photography.
Another question is, how is it able to locate where the nebulae are in the sky?
How's
Yeah, so Valerie, that telescope does a plate solve, so it actually it has GPS information from where it is, right?
Yes.
And then so it knows where it is, what day it is, roughly where it's pointing, and then it recognizes what it sees when it's
Exactly. It recognizes where you are. The GPS on it knows the latitude, the longitude, and it knows where it is in the sky. And that's the amazing thing, that for me it's perfect, being totally new to astrophotography, that all I have to do is press a button. and David just looked down on the floor when I said that, but I understand.
the Nakamoto shrug. We saw it. Okay, any other questions for Gary?
Any other questions up here? Okay, then thank you very, very much.
I grab it at the end if it's okay. We can eject everything all at once. All right, next up, who's next on our list here? We are looking for Ben Garlick. All right. I'm actually really looking forward to this one. This is going to be super cool. Yeah, you can grab it at the end if that's cool. This is how we're going to keep you in the audience. No, sorry, don't pull it yet. Yeah. Sure. There.
Perfect, thank you.
Yeah, I just want to make it big.
You got slack.
Cool.
Okay, and bam.
Coming up? Sweet.
Great success.
Yeah, is it coming up on the? There it is. All right, cool. Hey, I'm Ben Garlick. I joined the club sometime over the summer. Yes. Hey, now you can hear me. Ben Garlick joined the club. Here, I'll hold it. Over the summer, recently got a new to me telescope after observing for many years growing up. My favorite astronomical object to view is the moon. And I've kind of dedicated my life towards viewing the moon from closer and closer, and that's kind of what I'm going to talk about today. So I work for Blue Origin. I'm a lunar flight operations and mission planning engineer, and I'll talk a bit about what that means. But before that, I worked at Ball Aerospace on the IXP X-ray Observatory, and today is actually the 4th anniversary of it launching into space. So that's, I think, kind of cool. And it's been up there doing... Thank you. Up there, I've been doing really awesome high-energy astrophysics for the past 4 years now. But now I plan moon missions, and then so I build the flight plans for them, figure out how we're going to do it, all that kind of thing. And then once it comes time to fly, I'll be in mission control operating the vehicle. So first of all, about Blue Origin. So Blue Origin, you may have heard of us. We were founded by Jeff Bezos and some others back in 2000. We're trying to build a road to space for the benefit of Earth. We have a vision of millions of people living and working in space. We only have one Earth. It's really great Earth, I think. There's nowhere else like it in the solar system. We got a room of people who look at the sky a lot, and I don't think any of you have seen another Earth. If you have, please let me know. Make my work, well, redirect my work. Wouldn't necessarily make it easier. And to get there, we want to radically reduce the cost of access to space. Very expensive to get there. We recently launched our second New Glenn mission, which is our big rocket. We landed it on a boat, which is really, really, really cool. That's like, there's no sense of scale here, but that's like a 20-story building that's 7 meters in diameter that like landed on a postage stamp at sea. It's really, really cool. But we can keep flying these, and after you use something enough times, the cost per flight starts coming down. And then once we have that down, we can start harnessing the resources of space. Something really cool is on the right side of the screen there, it looks like you might recognize a solar cell. This was actually created from lunar regolith simulant. They have a process where they can turn lunar regolith, well, we're using simulant because we need to bring more back, to create solar cells. So looking forward, we can go to the moon, we can create solar cells, we can provide abundant energy on the moon, and while we're there, we can extract the hydrogen and oxygen from the ice that's in the permanently shadowed regions of the moon and in the regolith. There's also, popularized as a great sci-fi movie, Moon, Sam Rockwell, where they get the helium-3. We're not going to do it like that because that ends very poorly. But helium-3 is really good for fission power and that kind of thing. Because we have finite resources here on Earth for power. So why not look to space? There's also everything in the asteroid belt. There's some awesome rocky and iron meteorites out in the display hall out here. We can go get them. We can bring them back. We can extend our reach into the solar system with this. And the other goal here is, I love this picture, but is to inspire and mobilize future generations. We want to build a road to space. We want to have O'Neill colonies, all of this. It's not one generation. We need to make sure that future generations are involved and engaged with space, with science, with technology, with arts, with everything, so that we're doing this for a reason and our efforts will be carried on. So New Glenn's really cool, big rocket, designed to be reusable. We've got a really big fairing on it. So the first stage is methane and oxygen, both two elements that are very abundant here on Earth. Methane so abundant that's a problem, in fact, greenhouse gas being what that it is. Second stage, though, is hydrogen and oxygen. All of, you'll notice with Blue Origin, our upper stage and lunar stuff, as I'll talk to in a sec, is all hydrogen and oxygen because it's plentiful out in the solar system, moons specifically. There's water. You can create hydrogen and oxygen, water plus energy. You can get that out of there. So we're going to launch on New Glenn. So this is what I work on most days. It's called the Blue Moon Mark 1 lander. Really fancy with names here. Let's make sure I'm talking what I want to talk. Yeah, so this will be the largest vehicle to ever land on the moon once we do it. This is about 8 meters tall, so that's roughly 26 feet. For reference, the Apollo landers were somewhere around 20 feet. And we're going to land the most south that a lander's ever landed. We're targeting nearby Shackleton Crater, down by the south pole of the moon, the Aiken Impact Basin. Interesting about Shackleton is we're near these permanently shadowed regions. It's also where we're targeting for the Artemis missions of returning with NASA, returning people to space. To the moon. We have people in space. We have. As far as the spacecraft itself, it's got everything you need to land on the moon. So we're powered by a BE-7 engine, which is a, like I said, hydrogen oxygen, around 10,000 pound thrust engine, cryogenic. That's also capable of really deep throttling. So we can reduce that power pretty low down so we can come to a nice soft landing on the moon. Otherwise, you're trying to pulse it and doing all kinds of weird things like they had to do back in the day and didn't end so well. We've also got power on it on the top surface. We've got our solar cells. We have communications, and you can see our little high gain antenna there. We have star trackers to tell us where we are. Essentially, the vehicle does plate solving, as we call it here. And then we've got a nice suite of landing sensors that tell us where we are on the moon relative to the surface, so we can touch down safely. Or say, like with Apollo 11, you come across a boulder field. It can see the boulder field. It can avoid the boulder field, more importantly. So for the mission itself, we're going to launch on New Glenn. We'll go into low Earth orbit a few times there, check everything out, make sure things are working. We have to deploy our high gain antenna, do some other things like that. And then we'll go burn to the moon. So back in the Apollo days, they had to use the upper stage of the Saturn V to do that because of just their architecture. With this, we're going to do that ourselves. So we'll deplete some fuel doing that, get ourselves on the way to the moon. We haven't changed physics, so it'll still be a few days to cruise to the moon, do some more checkouts, testing. And also, I didn't mention this. This is a test flight. This is a Pathfinder. This is a prototype. So the point of this is to learn what we need to learn. It might go really well. It might not. That's the beauty of test flights, and that's the fun of test flights, at least to me. So we'll cruise to the moon, and then when we get close enough, we will turn around, burn our engine the opposite direction of our travel to slow ourselves down and capture ourselves on the moon. That's like the most critical thing, almost more critical than the landing burn to an extent, because you miss that, you're flying past the moon, you're hitting the moon, you go too much. It'll be exciting. So then we'll start orbiting the moon. We'll orbit the moon for a while, do more checkouts, image our landing site. We need to charge back up our batteries. Turns out running engines takes a lot of power. And we'll stream video back. That's what I'm really excited for. We can get some good views of the moon, better than I can get with my 8-inch Celestron at least. And then we'll come to a nice touchdown on the lunar surface. And you might ask, well, why are we doing this? Why send this one? We have a payload, actually. So the lander overall is capable of landing around 3 metric tons, so 3,000 kilograms, 6,600 pounds on the lunar surface. So for future flights, we're flying rovers for NASA and other things of that nature. But on this one, we have 2 payloads, relatively simple payloads. One is called Scalps. It's a NASA-furnished sensor suite that's a bunch of cameras that's gonna image how our plume, so our rocket exhaust, interacts with the lunar surface. This is the largest engine we've landed on the moon since Apollo, and the profile is just very different. It's also the first hydrogen and oxygen engine that will land on the moon. So the gas characteristics are a little different. We want to make sure we're not going to put a big crater under ourselves. So on the next one, Mark II, which is much larger, we have 3 BE-7 engines on this one. We don't want to make a giant crater and fall into it when we land, because that's a real concern. That would be a bad day. Or when we go back up, because Mark II is going to be reusable. So Mark II is our crew lander. This one can land much more on the surface because it can land 3 people in there. It's also twice as large. It's 16 meters tall, so over 50 feet. For this one, and yeah, you can see there's a little astronaut there. That's all to scale. This thing is giant. Like we in an atrium at work, we have the Mark I displayed. It wouldn't fit in the atrium for Mark. It barely fits in the atrium for Mark I. And this is part of the Artemis program. This is our return to the moon as America. But it's not the vehicle that will take the astronauts there. So how this one works is it launches on New Glenn as well. That's the beauty of that 7-meter fairing. You can launch really big things. It'll have to refuel a bit in Earth orbit before heading off to the moon. When it's at the moon, it'll enter lunar orbit, and the Orion vehicle, which launched on the Space Launch System, that is actually launching again in February. We're going to launch people to the moon again, to orbit the moon on Artemis. I can't remember the numbers, but the next Artemis mission. Thank you. Yes. I forget if they skip sometimes. Sometimes they skip numbers. But this one is slated for Artemis 4. So not the first landings, but the second set of human landings that we'll do. And it's basically a ferry to and from the surface. It can handle a handful of times going up and down. And the whole goal here is lunar permanence. We want to stay on the moon. We're not just going for flags and boot prints and all that. We want to stay on the moon. We want to create a destination for that road to space. Yeah, if anyone's got any questions, I'd be happy to answer them. Yeah.
What do you got, Shane? I'll read.
Recent robotic landers, are you concerned about it being tall and tippy?
It's a very good question. Yeah, so the question was, given the recent robotic landers, some competitors have tipped over upon landing on the moon. And actually, interestingly, they tipped over in a way that their antenna was still facing the Earth so they could communicate, which was very fun. Am I concerned about it? Yeah, everything's a concern. If I wasn't concerned about it, I shouldn't be doing this job. Yeah, we have a lot of people thinking about that, basically. A lot of simulations say we're probably fine. Of course, there's simulations, and some of them say, it can go either way. The landing sites we're targeting are a little more forgiving in some ways. But yeah, it's definitely a concern and something on everyone's mind. Yeah.
For the Apollo missions, there were separate orbiter and lander. Are you going to do that, or are you talking about just going straight from Earth and landing with the one thing?
Yeah, no, it is separate. So we're using Orion to get the astronauts out to the moon. It'll dock. Also, there's Lunar Gateway there as well. Possibly they'll both dock to Gateway, or it might be direct. But Orion will be what takes them out there, and this is just shuttle service up and down.
Okay, so there'll be a permanent gateway orbiter there, and you're going back and forth from the orbiter and then from there to the surface.
Yeah, exactly. The plan for Gateway is to be in a NRHO. It's a near rectilinear halo orbit, so it's this really wacky, almost unstable orbit kind of around the moon.
There's a lot of unstable orbits.
Yeah, very few stable ones. I'm not an astronomicist, so I can't quite describe it in a way that makes sense to myself, let alone anyone else. But yeah, so that'll be out there, and then there's good access to and from the lunar surface. So it also can serve as kind of a lifeboat. You're not having the best day on the moon, you can go up to the station.
We have a question on when is it launching?
Oh yeah, early next year. Spring next year is kind of what we're targeting. So it's happening quickly. I wasn't able to include the pictures here, but if you go to like Jeff Bezos's Instagram or any of that, he's got pictures of like the lander. It's built. It's real. It's super cool. I think I saw a question in the back. Yeah.
What is the timetable on the refueling tests?
Timeline refueling tests. I'm actually not sure.
And then how much AI, or will AI play a role in any way?
It certainly does in my day-to-day. I think everyone on the team uses AI in some way to help us. I mean, I use it to help me write code often. We're not playing on AI on board the vehicle necessarily. I mean, I'm sure there's some sort of machine learning at some level, but not AI in terms of like a large language model, that kind of thing. I'm sure they're investigating things for crew interaction, that kind of thing. But mostly it's a really good engineering tool to kind of mostly turn non-software engineers into poor software engineers.
Nice. All right, anyone else?
Yeah.
Greg.
Yeah, solar radiation on the moon. Yeah, it is a concern. We got a good amount of data from Apollo, and very small sample size, not quite statistically significant, but we've seen no increase in incidence of cancer among Apollo astronauts. In fact, they have quite long longevity, probably because they were in extremely good shape. Yeah, it's a concern. There are monitors that we've landed on the moon, and there's some future rover payloads I know they're looking into, not Blue, but NASA overall, to specifically look at biological interactions with radiation on the moon.
Are the ships shielded in case of solar flares or something, or you need to protect the astronauts on the spacecraft?
Not explicitly. A lot of that comes down to it's often oriented, and we're not hanging out in the Van Allen belts. Part of it is we want to transit the belts really quickly, because it's also not good for the craft itself. I mean, working IXPE, I've had the spacecraft reset because of radiation hits. It happens. I think I saw a question over here. Yeah.
Are other countries, experts, also able to be involved and lend ideas just to, open up the ideas a little bit more?
Yeah, Artemis is an international program. Yeah, Artemis is a very international. It's something called the Artemis Accords that the U.S. has been spearheading to get countries all over the world involved in this. And I think I can't remember the number, but at least dozens, if not 100 and more, countries involved in the Artemis program overall. I mean, I think the power parts of the modules come from Europe. I think Thales has something to do with their Airbus, one of them. Yeah, I mean, it has to be international. Actually, on the next Artemis flight around the moon, there's a Canadian astronaut. Yeah, Jeremy Hansen.
A question from Zoom. New Glenn, Blue Origin, and SpaceX are both building apparently very capable vehicles. But philosophically, is there a difference in how you approach it or what the capabilities will be? Is there room for both systems going forward in the long term?
Yeah, there has to be room for both. You really don't want to be single string with access to anywhere. I mean, accidents happen with systems. You can have something fail. You need both. There needs to be room for both. I think that's one of the really good things about how the government is currently funding and approaching things is there's competition between us. There's different approaches, sure. I mean, you get any group of engineers in a room, you're going to, you put two engineers together, you're going to get 5 different approaches, at least. But I think there has to be room for both. And I think that's one of the exciting things of where we are right now, is there is so much interest in returning to the moon and going elsewhere.
We got another one from Zoom. When you go, what are you planning on doing to prove that you are there? As someone who is in outreach and in education, I constantly run into the conspiracy theories, and the farther we get from the Apollo era without manned lunar missions, the more moon deniers we will have.
Yeah, I grew up in New York, and I take my telescope to the park and show people the moon. And people would ask me if I was showing them a picture. So I'm very familiar with this. We're going to send pictures. We're going to send video. If that's not enough to convince you, I don't know what else to do. Yeah, there's going to be tons of outreach with this. Blue has something, actually, I think there's a... I don't know where it is, but... Well, there... You can do that. You can. There was Project AIM-119 back in the Cold War where Carl Sagan actually was involved in this, and they wanted to nuke the moon to show that we could do it. Arthur Clarke wrote a story about it. Yeah, good story. Yeah, I mean, we're gonna try to convince. We're gonna do a lot of outreach, and I think some people don't want to believe it. It's a mental block. Yeah.
I want to know what it's like working with Katy Perry.
Different office. Yeah. Different office. She doesn't come to the El Segundo office. I'll put in a good word.
Fair enough. All right. Well, thank you so much.
Thank you.
All right. Next is Ernesto.
Get her to join the society.
Ernesto, what equipment have you brought? Excellent. All right. All right. We're ejecting thumb drives. We've got to that point. We've hit critical mass on thumb drives.
Next time. We know you got a laptop. Otherwise, I would have brought mine.
That's this one.
Yeah, but
All right. You recognize that one? No, yours is still in there. One at a time.
Yeah, that's mine.
They don't have the punch. And you don't want to make.
Hey, that's it. Okay, got it. I got it. Yeah, buttons. Okay. Oh, sweet. Whoa. Okay. Oh. 1 sec. I want to make sure I'm on time, so let me get a timer. Okay, hello. Yes, hello everyone. My name's Ernesto. I'm a museum guide here at Griffith, actually. Yeah, woo! Yeah. So if you've been to one of our star parties, I've probably helped move your telescope to your car. So if I look familiar, it's probably from that. But apart from working here at Griffith Observatory, I'm also a physics master's student at Cal State LA. So what I'm going to talk about today is my research that I'm doing there as part of my master's thesis. I'm working under Margaret Lazzarini. This is her work. She does high mass X-ray binary stuff. So spectral classification of and radial velocities of high mass X-ray binaries. That sounds really scary, but by the end of this, you will all know what that means. All right, so this is a high mass X-ray binary. HMXBs for short. So it's basically a system. It's a compact object, which is either a black hole or a neutron star. And then the other object is just a star. The star is a really big one. It's a high mass star. It's type O or type B. Those are some of the biggest stars that we have out there in the universe. So what's happening is the compact object, they're orbiting pretty close to each other. And as the star is orbiting around it, it's emitting a lot of material in the form of stellar wind. And the stellar wind will be caught by the compact object, and it's kind of orbiting around it. It creates what we call an accretion disk. That's what that thing is right there, accretion disk. And this accretion disk has all this material basically rubbing up against itself. It's really, really hot. And when things get really, 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 really hot, they emit X-rays. And that's where the name X-ray binaries come from. So it's all it is. It's just two stars, the compact object stealing stuff from the big star, which we call the donor star. And then when it gets heated up, this material around the compact object, it just emits X-rays. So the focus that the area that we're looking at is the Triangulum galaxy. It's M33. M33 is a galaxy that's outside of our Milky Way. It's part of our local group. And my project is basically looking at these HMXB candidates. So we don't know for sure if they're HMXBs. We just want to know if they are, so we can further research them. And the catalog that we're looking through come from these two surveys of M33. The first one is the Chase M33, and then the other one is FATTER. We're really good with names in astronomy, right? So Chase M33, that was a Hubble survey. So the Hubble telescope looked at M33, got these candidates, and then we followed it with, Chase M33 was with the Chandra X-ray Observatory. So Space Observatory, it looks in soft X-rays, which is below 10,000 electron volts. This space satellite looked at M33, saw these X-ray sources, and plotted them. FATTER was the Hubble survey of M33, looked at the galaxy, and then plotted those as well. There we go. So yes, specifically for my research though, I am using the Chandra data, but the Hubble survey of M33 was followed up with the Keck Observatory survey. So Keck Observatory is that image to your left. Yes, to your left. It is based in Hawaii. It was at a time the largest telescope, but now it's been eclipsed by a bunch of other newer and fancier ones. So specifically, what we're using from the Keck Observatory is this tool called Deimos, and basically it's able to take like the light from up to 100 galaxies and take all the information from those galaxies, and we can get that and go through it, and we're able to get data from it. So that's the tool we're using for my project. So again, we had these surveys with the Chandra X-ray telescope, which is actually the one on the right. We did another survey with the Hubble. We found these interesting stars, which you think are HMXBs, and then we followed up with the Keck Observatory just to confirm whether these are HMXBs or not. And just to give you an idea of what these look like, so on the left is actually what you would see like in the visible light telescope, like Hubble or the Keck Observatory. Really pretty picture, right? Kind of like the ones we saw earlier right now, right? Really good image. The one on the right is actually an X-ray image, so not as exciting. You're not going to get a lot of likes with that one. But it's still very, 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 very cool, right? So if we notice that we have a visible light source, like so we have a big star there, but then we also notice that there's an X-ray source there, that leads us to believe, okay, there might be an HMXB there, right? So we have a catalog of about 50 HMXB candidates, and that's what I've been going through with my advisor. And here's how we do it. So we get this light from a star. As it reaches us, it's going to pass some gas, some clouds, and stuff like that. And as it does that, the light basically energizes a lot of the atoms in the cloud. And when we see that, we call it absorption or emission. When the light hits the gas, it excites some of the atoms in the gas, and then they go up an energy level, and that we call absorption. And then, when it's up the energy level, it wants to go back down to where it originally was. When it goes down, we call that emission. And that's basically what we see when we're doing what's called spectra. So spectral classification, we're looking at the spectra of these stars, the light of these stars, and from that we can decide what kind of star it is, what elements make it up, and a bunch of other cool things. So the elements that I'm mainly looking for are helium and hydrogen, specifically these very specific versions of helium and hydrogen. We have helium-1 and helium-2, and then hydrogen alpha and hydrogen beta. And these are just basically it's the same gas, but it's just at different energy levels. That's the only difference between the alpha and the beta and the 1 and the 2. So one of the papers that I had to read to understand this project was from this astronomer called Philip Macy. And him and his team, they basically had this flow chart. I simplified it down because there's a lot of branching things that I didn't want to confuse you guys with. So this is basically it. Is helium present? Yes. Okay, cool. We got a big star. Is there only helium-1? Okay, it's going to be a B star. Is there helium-2 present? That means we have the largest stars out there. That's a really hot star. Or they're both really hot. So this is what I'm doing. We get the data from the telescope, so this would be Keck observatory data. I put it through some fancy little code that breaks on me all the time. But when it works, I get something like this. And you can see in that little bar in the middle, it tells you all the lines of the elements that we're looking for, right? So there's helium-2, and on the bottom is the wavelength where we see that line appear. And then you could see these little dips, right? So up is emission, down is absorption. That's how we tell the difference between them. So just looking at this one, what do you guys think this is? Type O or type B? That's right, type B. Yeah, type B. If you look very, very closely, I'd say it's helium-2 at 5411. There's a big spike there. All right, what about this one? Type O or type B? Correct, type O. Yes. Yeah. So type O, really hot star. This is one of the biggest ones. So this is a really good star. All right. So now radial velocities. I want to know how fast these stars are moving. So if we see that these stars are moving, that would tell us not that they're HMXBs, but they're in a binary system, that there's something there that's causing it to move really quick. And we kind of do the same thing. We look at these lines of hydrogen and helium, and then we're able to determine how fast they're moving based on that, on this thing called the Doppler shift. So in a lab setting, a perfect scenario, right? We look at these, we do the hydrogen and helium spectra ourselves. We look at the absorption emission lines, and we get a value for where it should be. In space, though, we don't have perfect conditions, right? It's far away, there's stuff in the way, and they're moving. So that's going to cause the emission or absorption lines to kind of move around a little bit. And by seeing how much they're off from the perfect lab measurements, we can calculate that and see how fast they're moving. And that looks like this. So you have these giant emission spikes, and those red bars is how much it's moved away from the actual lab recorded values. And if you look in the middle of the graphs, you have speeds of negative 248 kilometers per second. You might be thinking, why is speed negative? I thought we can't go back, whatever. So that just means that it's coming toward us. So that has to do with basically redshift and a lot of these things. So if we see it coming, moving away from us. If it's redshifted, it's moving away from us. So we're seeing these negative speeds, and that's telling us, okay, that star in M33 is just in a position that's moving away from us, and that's how we're able to determine these speeds. And then we get these error bars, those red bars. We're able to plot them, and we get something like this. This is called a radial velocity curve. And if this is kind of an ideal scenario where we want them kind of to be all over the place, because this tells us, okay, it's moving erratically, there's something there. That star is moving. So why do we care about these HMXBs? 3 reasons. Because, one is a black hole or neutron star. That's a star that's already lived its life, and its companion is still living its life. So this is kind of like a midpoint in stellar evolution. We can kind of see like the timeline of what a high mass star will go through. Once the star will actually die and blow up, become a black hole or neutron star, then we have a binary neutron star, maybe black hole neutron star system. And maybe at some point in the future, if they're spinning around each other, maybe at some point they will get to a collision point, and from this collision you'll have gravitational waves. Gravitational wave physics is a really big thing right now, so studying these could probably be a source. Some of these could probably be a source of future gravitational waves. For cosmology, if you look at this graph right here, there's this part called reionization. So early in the universe's history, there was a period where stars were forming, and we think that these HMXBs, because they evolve so quickly because they're high mass stars, maybe as these X-rays are coming off them, these X-rays are heating up gas around them, energizing this gas, and now this gas makes new stars. So we're thinking maybe these HMXBs early in the universe's history also helped in a star formation. So that's how we should care about HMXBs. Any questions? Not all at once, guys.
I have one actually.
Oh yeah.
So yeah, what led you directly out of our galaxy for why you were looking at a triangulum galaxy instead of anything local within ours?
Good question. Yeah. So why are we looking at M33? We already have all these candidates, right, for HMXBs, right? So my project now, looking just at Keck data, we had about 50 stars, 50 candidates. Previous observations from the FATR and Chase M33 survey and other observations from ground-based telescopes got around 100 other potential candidates. So we're looking at about 150 stars for potential candidates for these. M33, because it's outside of our Milky Way, it's really close. So we can actually pick out individual star systems. So that's the luxury we have of choosing it. As far as why we didn't look here in the Milky Way, M33 actually does have one confirmed HMXB, and it's M33X7. So we saw that for sure there's one there. Okay, we want to look where they're at. We know there's one there for sure. We should probably keep looking here too. Yeah.
All right, and you know what it looks like.
You'll
know when you see it.
Yeah, you'll know when you see it, right? You can look up the Chandra image of M33X7. It's just literally like a blue little dot. Very cool for me, but some people might not find it interesting.
Mike, what do you got?
Is there a resolution? Is Keck better than Chandra? Is one telescope better than the other?
Yeah, good question. So is Keck better than Chandra? So Keck is for visible light, so light that our eyes can see. So if we want to detect the stars that are in this system, Keck would be the best way to go. A visible light telescope would be the best way to go. And Keck, like I said, it's a very large telescope, 10-meter telescope, so that would give us a lot of information from the stars because we're collecting a lot more light. Chandra is an X-ray telescope, so it's not going to see any visible light stars. It's only going to see the X-rays coming off the HMXB. It's only going to see the X-rays coming off the black hole, the neutron star, whatever's there. So that's what we have to use too. If we just only try to use one, we'd be missing half the story of the HMXB because we're seeing light that we can't see with one and the other.
Yeah. Anyone else here? Right here.
Yeah.
So it looked like in the kind of model and picture you showed that the companion star is actually being influenced enough by the gravity of the massive compact object that it's actually kind of seriously distorting the shape. Mm-hmm. So is there modeling or simulation suggest that would potentially actually be the case?
So it depends whether it's a black hole or neutron star. And and then you also have to throw in mass, how close they are. In that image right there, that was something that we call Roche lobe overflow, where the objects are big enough and they are close enough that it actually will start just taking things directly from it. Most HMXBs get their material, like the material transfer, the accretion, from just stellar wind. Just because these stars are so massive, they're ejecting a lot of material that this material is just being caught. But there are specific cases where if they are close enough, they'll just physically just take it from the star and kind of warp it like that in the image. Yeah.
The Doppler velocities you're looking at, is that that's the motion of the system away from us? Can you see the rotational velocity of the system?
Yeah, good question. So that's actually something we have to take into account, right? So, the galaxy's moving, we're moving, these systems are moving. So there's a lot of movement in there. And in the code that we're using, it basically subtracts a lot of that movement out. So all we're left with is the orbit or the motion of the star that we want to focus on. Yeah.
I'm trying
Oh, no, we're getting the rotational velocity of the star itself. So just as a star is, it's orbiting around its own axis, yeah.
What are the periods of these binary systems that you're looking at?
That is beyond the scope of my research. I'm not, it's my favorite answer as an astronomer, right? People ask me these things. I'm not necessarily focused on how fast they're moving. I just want to see if they're moving fast enough. So there are other stars in our survey that we had speeds of like negative 180. And while that's impressive, we don't really care how long it takes to go around it. I just want to know if the star is moving fast enough for us to pique our interest. So if we get the radial velocity, we know that there's a binary system there. It's up to other astronomers who, if they want to figure out the mass for this system, then they can, if we get the mass, we get these other parameters, then we can conclude if it's an HMXB, and then we can get other data like the period of rotation, how long it takes for them to go around, and stuff like that. But for right now, I'm just focused if this star is spinning faster than we normally see stars spinning. All right. There have been low mass X-ray emitters, but the X-ray emission really just comes from how hot the accretion disk comes. So, X-rays come in all forms elsewhere in the universe. It just comes from really, really superheat objects. So as long as you got enough heat, you can get some X-ray emissions from that. Yeah.
Okay, we have got to move on. Well, thank you so much. That was awesome. Very good. Okay, Mr. Whitaker.
Sorry, folks, I don't have any fancy electronic stuff to aid me. I had some technical issues trying to get stuff to work, and I was on a very restrictive school Wi-Fi earlier, so I couldn't even get on my Google Drive or anything. So, my name is Stephen Whitaker. I'm one of the museum guides here, like Ernesto, and so you may also have seen me pushing your telescope cart, or often on a Saturday as a lead guide, maybe coming out and joking around with Evan. But what's also relevant is that for a couple of years, I had switched over and I was a telescope operator. So I switched back because I like being a guide better, but I do still have that experience. I have those skills, right? And basically, you may not know that I'm also a substitute teacher. I work for several different school districts, including one where I believe I met one of the gentlemen on the call here when he was working there. But I also have lately been doing a lot of my work for Monrovia Unified, and particularly at Monrovia High School. What you may also not know is Monrovia High School is one of those rare high schools that actually has what they call on the door an astronomy center, but it's really a small observatory. And I sort of gradually became aware of this when I was only doing so much work for them, and it's only been more recently it's become almost sort of my home district where I get more of my work from. And at the time when I first became aware of it, I didn't really realize how much of a telescope they had in there because the dome looks really small. And you have to think about, well, wait a minute, but remember how compact a fairly large Schmidt-Cassegrain can be, and I didn't process at the time. And I knew that some of the teachers taught astronomy, and I was like, subbing for astronomy second period? When does a high school have an astronomy class? So I, again, gradually became more aware of this, but I've become more aware of it lately, partly because just had a random conversation on C14. It turns out it's actually a C11 Edge HD, which is also pretty cool, right? That a high school has a telescope that large and powerful in their dome. Now, unfortunately, what's also happened, and I also just gradually became aware of this, is due to a sequence of unfortunate events, the program has kind of become pretty much defunct because of different things happening to the three different teachers involved. One was the unfortunate passing of Pam Thompson, and one was also then another of the teachers. He was basically let go for what they call RIF, reductions in force, and he now works at a different school. So he's literally not working at that school. He's working in a different district. He still tries to stay involved, but of course, there's limits to what he can do and how much he can be present. And then the third teacher, I think he was still trying to do some things. He was a little bummed out that they, at a certain point, stopped being able to offer the class. But then he lived in Altadena, and then the Eaton fire happened, so his house burned down. And then, he's living at his in-laws. He's, just trying to get done what he has to get done, do all his teaching. And if you don't know,
classroom teachers do a lot of stuff, and and especially if they're trying to do it right. So he's limited in his time and energy, and he's having to deal with his own situation, and it's not the easiest thing. And so things just kind of stopped happening. And at a certain point, I was talking to a different teacher that I didn't know particularly at the time had any interest, but we were just doing some shop talk at her club fundraiser, and she happened to mention the guy whose house burned down. And I know him a little bit. I'd subbed for him before. So I went, wait, maybe I should go talk to him and see if there's a way I can help out with this and help get this going again. So I did go and talk to him, and he went and he showed me the observatory and some of the stuff there, and we fortunately recovered the telescope with the tarp because it was uncovered, and then there was some rain later. And then he took me to talk to the principal and met him, and we basically formed kind of an email chain with the four of us guys, which it's been a little bit interesting trying to work with the limitations each of us has and trying to get something to happen. We tried to get something to happen before Thanksgiving, but then the weather actually did turn out the way it was predicted, where it was not real good weather. But now we've sort of gotten our thing together. Partly helpfully, this other teacher she's become involved, and she has these energized, very good kids, these robotics club kids that are all into it, and they're helping us to publicize it for other kids that might want to view along with the astronomy club. So we're doing a viewing this Friday, all other things being equal, but the weather's looking good. And it's on paper, it's basically for the astronomy club, but again, those robotics club kids will probably be involved, and they're helping to popularize it to at least other kids that might be interested in the astronomy club. And sort of the vision, of course, is not just to have that club be involved, but that also at times some of those kids, once we've trained them up to use that C11 HD, and maybe they also have some smaller Nexstar, they're like 5 SEs or something, maybe 6, and have some bigger public events, because of course it is also a school district and community resource to have that observatory and those telescopes there. And so it's a thing I've been working with, trying to help out when I can. It's of course a little weird for me. Also, it's one of my difficulties being a sub. I'm not always there, and people don't necessarily take you seriously when you're a substitute teacher, unless they actually learn, what you can do, what your skills are. But it's a thing, and it's happening. And I have gotten into the dome and seen what they have. They have a number of eyepieces, but so far I haven't gotten into certain roll-up cabinets. I'm not sure if they have as wide a field of view ones as Vanessa had actually told me might be good ones to have to take advantage of that Edge HD mirror and the sharpness all the way across. So that might be something we are looking to source in future, 2-inch eyepieces. There is a white light solar filter. I haven't seen any H alphas for any of the scopes there, and they have a number of small refractors, so that might be a good thing for maybe use for some of them. Again, they have a number of eyepieces overall. They have a moon filter for the 1 1/4-inch eyepieces. I also saw something that looks like a back-end sun filter, which I've never seen before, and I would be cautious about using because I don't know how that works. It says sun, and it's about this big, and it looks black, but I was like, I don't know if I trust this. I don't know what this is meant to be used with. They also have some Barlows. So they've got a good range of equipment in general. There are some things could probably help with. If we did get 2-inch eyepieces, it might need a 2-inch moon filter, some things like that. And it seems like, again, some of this communication has sort of been roundabout and not gotten through, but Tim actually told me that he and a colleague got in there to kind of check it out at the behest of Dr. Rainwater, the principal, before the fall holidays, and it seemed like everything was good to go and in good shape. I don't know, were you able to check the collimation of the secondary?
No, I didn't, but Tom Traeger told me that he thought everything was in good shape, and of course you already talked about it. He's going to help out.
Sure, yeah. Cool. So I wanted to come here and talk to you all about it. I mean, it's obviously, again, Evan and Norm helped install that, and Tim, was married to Pam, and so has that involvement, and kind of mention it as a thing that I'm trying to help with. And in future, we may be with some of this other equipment that might be helpful. We may be looking to acquire whatever it is, donations, loans, low-cost things. Of course, it's a school district, and even though Monrovia isn't super poor, school districts everywhere are facing a lot of budgetary issues and cutbacks right now. So it's not something they have a lot of money to spend on. There is some equipment that Tom has suggested we might be able to sell, because particularly he's looking at the dome that they have there is a little old, a little rickety. It's kind of primitive. You have to pull on ropes to do everything. There's no motorization. And we've been having trouble getting it to close fully. That's why we had to keep the telescope under a tarp, because a little bit of the rainwater did get in. which is kind of ironic. That's the principal's name, but I don't know if there's a connection. So that's what this project has been that I've been involved in, and it's been an interesting journey. I'm sure we'll continue to be. I'm looking forward to Friday. It should be good. So I don't know if anyone has any questions.
Eric.
Oh, it's Monrovia High. It's the main. Monrovia, I think, really just has one regular high school. They also have Canyon Oaks, but that's more like a continuation and non-traditional. Yeah.
Do they ever have like public viewing where the public comes over?
So they've done that in the past, but that's one of the things that's changed with these unfortunate events and just not having the people involved that have all the energy and everything is they haven't been able to do that in a while. I think Tom was saying it might have been a year and a half or 2 years since they've really been able to do much with that facility. So that's what we're hoping to change and to keep it changed, to keep moving forward and have more stuff happen. And I think having all 5 of us involved and having those energetic robotics club kids making flyers and stuff is really going to help.
They were learning imaging at some point too, so we may somewhere down the line be asking for some imagers to help volunteer.
Okay. All right. Real quick, we got to clip on.
I'm not sure if I have a question or not, but as you know, we have a robotic telescope. As you know, we wanted to make either imagery or opportunity for time available for educators if you guys need it. So if there's interest out there, we have tens of thousands of pictures available for consumption, and we can provide time for kids to robotically. So keep that in mind. I don't know what the goals are of that program, but
I mean, I think we have multiple goals, but that sounds like something that might be interested in. So I'll keep it in mind. Thanks.
Especially considering that setup, it's a much wider field of view than the C11 would be. So for a larger object, that's actually a better fit for some stuff. Yes, the hallowed skies of Monrovia. Yes,
One
yes.
quick question.
All right, well,
on
thank you
Zoom.
very much.
yeah.
All right, I think Christina will be next. We're going off into Zoom land for the final 2 presentations.
Yeah. Hi, everybody. Can you hear me okay?
Yes.
Awesome. Okay, let me share my screen and start from the beginning. So, good
Yeah.
day, mates. I'm
Good day.
in Australia right now in the Southern Hemisphere. And this is my 2025 trip to Australia, New Zealand back in February. So in the summer here, still pretty light out. I'm Christina. I'm a new member as of this year, along with my partner, Ben Morrell, who had surgery down here today, so he's not on. But first, I went to New Zealand back in February, specifically Lake Tekapo, New Zealand, where I was with a friend where we went camping and stargazing at the summit of Mount John, which has the University of Canterbury Mount John Observatory. So at the top there's really a thing called an Iorki Mackenzie International Dark Sky Reserve. It's one of 22 worldwide dark sky reserves, and it was the largest one at the time of its designation in 2012, and it's still the largest one in the Southern Hemisphere. Now, this first photo is just of the moon rising, that the moon didn't get the hint when we were there to keep it a dark sky. But this is kind of the logo of the Dark Sky Project in New Zealand. They try to connect visitors with our night skies and try to ignite a lifelong passion of dark sky preservation. So specifically, this is what it looks like up at the top of Mount John. They have a few different domes. They have a few different buildings where students are doing research, but they also bring people up. So I thought it was really cool how they light up the domes and then just obviously the stars that you can see in the Southern Hemisphere that we can't see up here. So this is a view from the dome of the Southern Cross right here. Again, it's not that impressive just because we did have a full moon that night. But what is impressive is that you're at super high elevation and the dark skies and just what you see around the actual cities and the lake. Everyone uses really nice lights so that it doesn't cause very much light pollution. They also give you these cute jackets that are for actually South Pole astronomers. So really, really heavy jackets that keep you nice and warm in the super cold high elevations down there. Then we went to Australia, specifically Warrumbungle National Park in New South Wales. So we did some hiking and stargazing, specifically at an observatory that was an Airbnb that the actual people built into their own observatory, as well as Siding Spring Observatory down by the national park. So as you're driving into what's called Kookaburra, It's a region in Australia. You get this nice little view that says it's the astronomy capital of Australia. Absolutely amazing. And then this is of the Airbnb. So it's personally created. The people are just interested and amateur astronomers. They built an entire sky deck over here. And then they just house their telescopes, specifically a 16-inch Dobsonian telescope. And then they personally built their own planetarium dome where they like to show videos that they've got from around the world. And then they have a non-operational radio telescope as well that is just sitting in their front yard. So this is kind of from the front view in to that kind of planetarium dome that you're seeing over here. Now, when you're looking at these pictures, this is just from my Pixel phone. So using the astrophotography feature, you can see here we're kind of pointing towards the South Celestial Pole. And on the left is the Milky Way. And then we have the Large Magellanic Cloud and the Small Magellanic Cloud. So again, the moon was pretty full as it was coming up, so we were able to capture these about an hour before the moon rose. But it was just absolutely amazing that we weren't really planning. This was a gift that we came to this observatory, Airbnb. And so these were just with my phone. I didn't have any other camera. So just by doing a long exposure, we had absolutely beautiful dark skies. And for the first time in my life, I saw the Large and Small Magellanic Clouds, which is just absolutely amazing how beautiful they are and how much is within them. So another way that I tried to back it up so that you could see the Southern Cross is kind of facing this way. So from top to bottom, left to right, how you would normally see it, with that other very, very important star that kind of shows you which one when you see kind of four that look like a cross. But then you're not really getting the view of the Small Magellanic Cloud down here. Now, specifically after that, we went to the Siding Spring Observatory. They celebrated their 50th anniversary of their telescope. But right when you walk up outside, you can see a bunch of the absolutely massive domes and buildings, and then you get to be your own little meteorite coming into Australia. So we thought that was very funny. And this is really what the entire Siding Spring Observatory site looks like. So it really kind of made me think of Mount Wilson Observatory and all the different locations you can go within it. I do have another picture of what each of these buildings are, but they have active astronomy going on. I've heard stories of people collaborating in the US and Australia when we were down there, but it's right up against the Warrnambool National Park as well. So I have a picture of that. Now, we got to go in the dome, but not necessarily look through or do any observing. But this is the 50th birthday celebration of their Anglo-Australian telescope. So it celebrated its 50 years at the end of 2024, but it's a 3.9 meter, 13 foot or 156-inch telescope. And it's absolutely massive. I'm using a wide lens camera phone just to take that picture. Now, from the view of kind of where we were looking at that meteorite picture, this is Warrnambool National Park. So I just like to show this. It's where we spent the day hiking before coming here. It's absolutely beautiful, and I think it really challenges a lot of the views we have within our LA observatories as well. And then finally, no Australia trip is complete without a kangaroo. So there's kangaroos everywhere, all over the national park, all over the observatory, kind of just guarding it and having some fun. And lastly, I thought it was really cute. From the actual Siding Spring Observatory, they have a sun, and then any path you leave going around New South Wales, so the state there in Australia, they have each of the planets to scale by size, but also as distance as you drive away. So as you're getting closer to Kookaburra and Warrnambool National Park, which houses Siding Spring Observatory, you get excited as you start to move back towards the observatory. And it's just a really beautiful way of showcasing something that we have at the observatory, at the Griffith Observatory, in the depths of space and out on the front lawn. So with that, I'll leave you all as well with a really cool just video that we took time lapse after the sun had set over the national park of just Venus setting. So if anyone has any questions, feel free to ask. I have all the links for the different things we did in New Zealand and Australia. But even though it was summer, it was absolutely outstanding. I highly recommend it. And then I really loved what we did of showcasing the southern sky at the Griffith Observatory Planetarium earlier this year, because I think it is just such a disorienting and really exciting experience to go into the Southern Hemisphere and see this. Thank you.
Awesome. Thank you very much. Okay, so we are running a little short on time. So Christina, that was really awesome, but I think we need to get to our next presenter right away. Is that all right? Throw some. Yes, right. Yeah, there you go. Make a bulletin article out of it, and then you can be famous. All right, Teresa, you're up.
Okay, I assume you can hear me?
Yep, and I can see you too.
Share screen.
Then share.
Share. Okay.
From the beginning.
From the beginning. Greetings from Tehachapi. For those of you that maybe are new to the area or don't get out a whole lot, Tehachapi is a mountain range area that's between the Central Valley and the Mojave Desert. So we're up at about 4,200 feet here. Obviously, you can see I have the LAAS logo, and the local little club here in our valley are the Bear Valley Springs Astronomy Club. So what did I do? Just recently, I earned my Master Observers Award from the Astronomical League. And if you haven't gone to the Astronomical League's page and looked at these observing projects, they're an awful lot of fun. I did work in astronomy as my career, and when I when I'd retired and gone to pulling out my personal telescope, I found that I kept looking at the same objects over and over again. And when I started doing some of these observing projects, it really made me go find more unusual objects that I never possibly would have gone and looked at before. So far, I found that I've really liked to sketch my objects. So far, I have sketched all of these different objects: Messier, Caldwell, constellation, sunspotters, asterisms, double stars, solar system, and yes, all 400 Herschel 400 objects. And currently in progress, I'm about halfway through planetary nebulae, open clusters, and globular clusters, and I need to buy a filter before I start in on bright nebulae again, because I think I'm going to need a very nice ultra high contrast, because I was not seeing a lot of those guys. What equipment have I been using? Well, I am fortunate that where we live, we have pretty decent skies. I'd say most of the time the average skies are Bortle 4. Best nights we might get slightly into Bortle 3 skies. We have a backyard observatory where we have a C14 on a Paramount, so that makes life very much easier. And we do go camping down in the Mojave Desert now and again, and I take a 16-inch Dob or a 5-inch refractor with me. I guess I'll go to the what do I use? I'll continue on here. What do I use to sketch with?
Teresa, we can't see your slides.
You can't see
Like
my slides?
Yeah, you're not advancing. We're still on the first page for us.
Oh, how bizarre.
Stop sharing.
Maybe I'll start sharing again.
Go to share.
Share. Click on
This one.
this one. Share. Are you seeing that?
There we go. Now we're, yeah.
Okay, yay.
Let them see the previous slide briefly.
Okay, the previous slide.
Click in this.
Okay, this is the previous slide, just what I was talking about. So move forward again. This is when I set up to sketch. I have an aluminum box for sketching. Inside I can keep my log sheets and pencils, erasers. I use number 2 pencil and what's known as a blending stump. It looks like a skinny piece of fabric that's compressed together that allows you to soften your image rather than a lot of people do. They lick their finger and move their smudge it around. but you can't erase that very easily, and you can't control it very easily. With one of these blending stumps, you can. I suggest using a really good eraser. I use the Mars plastic Staedtler eraser. When I make a mistake, I want to make sure that it's completely off my page. I have a red light. It's an LED red light that I think I got from Walmart that has 2 layers of the reddest red nail polish I could find, and that works very well. I generally sketch, it takes me I only spend about 10 to 15 minutes on each sketch when I am sketching. I draw the star field first and then use that as markers to put in anything else that I'm going to be drawing. I do use some post-processing as a joke. When you're outside in the cold, a lot of times your stars aren't terribly round, or you might make some sort of mistake. So I come in afterwards while it's fresh in my mind. I erase the yucky stars and make them nice and round. And if there's some detail in a nebula or something that I've drawn and I know that it's there, I'll go ahead and add it in. So now I'll just show you some examples of the stuff that I have sketched, and I apologize, it's not the greatest. I tried scanning it, that didn't work. So these are photos with my phone. But anyway, these are solar sketches that I did for the Sunspotter program when it was active a few months back. Some nebulae, obviously that's a crescent and the veil and the helix. A planetary nebula, and I didn't notate which one it was because I have a ton of them, and a globular cluster. Sometimes the globulars take a long time because if I see a modeled globular, I sit here and put in lots and lots and lots and lots of little teeny little points of stars. Open clusters, I think everybody probably knows which open cluster that is. And this is a generic one. Again, I didn't notate which one specifically because I have quite a lot of pictures of open clusters, and I think that was actually the cluster right there. Galaxies, this one's NGC 4656, and of course Omega Centauri. And asterisms, I just finished that, and this is a really fun little project. It's a collection of stars that are in patterns. This is the double triangle asterism, and this, a lot of you probably recognize this as the owl cluster, but in the asterisms list, it's called the ET. In this list, there are things that look like Christmas trees, canes, there's a rocket ship, an emu, a kangaroo, and I'd say like 85% of these asterisms, you find them, look at them and go, wow, it really does look like a whatever. And the other 15%, I'd say, what were they smoking that day? But anyway, that's just some examples of the sketching. And I really, really do, if you feel like you're getting stuck looking at the same things, or you want a little bit of a challenge, go to the Astronomical League page and look at these observing programs. They really are an awful lot of fun. And just as a last thing, just for the heck of it, I started doing some for fun. These are my first few drawings I'm doing from Hubble and the Webb telescope on black paper. And I'm starting to learn how to use colored pencil on the black paper. So that's my next little thing. So that's it. I just wanted a really quick little thing. And so get out
Thank
your
you very much,
pencils
Teresa.
and have
That's
fun.
awesome. Awesome. As a quick aside, actually, I started, you've showed us Centaurus A once before, and it's become one of my favorite objects based on your drawing. I actually seeked it out.
Oh, thank you.
And that's because of you. It's because of
Oh.
you. Okay, I'm going to do a speed run because we've got 5 minutes, and then everybody run for the door. Okay, real quick. Good Heavens is going to go to Ted Moss, and my bit for this is if Ted Moss is the patron saint of SCAS, then Ted is its guardian angel. Ted has put an immense amount of himself into getting our dark sky site clear of county violations and made it safer for all of us. He's also on a first name basis with the land use consultant, civil engineer, structural engineer that are guiding us through the development of the Lockwood 5. And without him, the dream of a house up there would likely stay a dream. He has the same willingness to roll up his shirt sleeves to load a dumpster full of scarce trash as he does to slalom through endless phone calls and make sure that we are making decisions that will benefit LAAS for generations to come. We are so lucky to have him among us. Thank you, Ted. I think I saw him out there. Okay, upcoming events. We have the next general meeting is going to be the banquet, like I said, on January 25th. Next Griffith Park Star Party here. 12:20 outreaches coming up. Silver Lake this coming Thursday. The next big one is going to be in January, I believe, on the 22nd. We have Santa Monica on 12:20. I think school outreaches are done for the year. Family night also done for the year. The next Dark Sky night is going to be December 20th. The next Mount Wilson Star Party is on the 13th, also the last one of this year. All the 16th nights are done. The next board meeting is going to be January 7th, and the next Lockwood Committee meeting is TBD based on what our civil engineer and land use consultant tell us is going to be. Good night. Oh, we're going to do door prizes? I mean, we have like two. Yeah, we don't have time for it. Okay, well, all the the gifts were given. The gifts are given by the presenters. Thank you. Good night.